Thank you so much for having me. I'm Doug Sillars. I'm talking to you from Southern Maine today. So we're all in the same time zone. I hope you've got your cup of coffee in front of you and you're ready just to sit down and have a great day of talks and hackathons and such. So let's just talk a little bit about how we can implement video on the web. Let's see. So I'm Doug. Nice to meet you all. I am the head of developer relations for a startup called api.video. And so obviously api.video, we're all about getting video out on the web with our API. I have spent years in the web performance space, helping people do audits on their apps or on their native apps, or also on their websites to make to make sure that everything runs quickly, because obviously a slow site is a bad site. I wrote a book called High Performance Android Apps a few years ago. It's for a really old version of Android, but a lot of the tips still hold. So if you want to download it for free, the bit.ly link will get you there. And then if you ever have any questions about this sort of stuff, I'm the only Doug Sillars on the internet. So Twitter, email, and my website are all just my name, which is fun. So we're going to talk a little bit about video. And when I think about video on the web, I think of two things. I think of video on demand, and I think of live video. We're not going to get into live. Well, we're doing live video right now, but we're not going to talk about live video and how you implement it. Video on demand, I think of it two ways. You've got short videos that'll be on a web page, or you maybe have a streaming video, like a Netflix or maybe a conference talk or something like that that's been recorded and you want to watch it. Short play videos include the background videos on web pages. We'll see some examples of that. The hero video up at the top of the page. Short informational videos, videos that loop that look like a GIF. And then we'll talk about streaming videos as well in a second. Now, of course, the biggest thing when you're talking about videos on the web is that videos are really, really, really large. If you have videos on your web page, it's probably the largest thing. If your JavaScript is bigger than the videos, you've got other problems. That's another talk. But if we look at this is from a year and a half ago, I guess, but this is the total kilobyte size on a web page. So the median web page is about 2 megabytes. If you have a site with video, the median is now 5 megabytes. Right. So as soon as you start adding video to your web page is going to get a lot bigger in terms of tonnage, just because you're adding these giant files. 250% larger. Videos are large, right? So the median video is 25% of your page. So when you talk about web performance, if you have a video on your web page, browsers are smart, and the videos are usually the last thing downloaded, unless you tell the browser to speed up the download to make the download faster. And so this is a waterfall chart, and a waterfall chart shows you all of the requests. Each line is a request. The colors are what type of file they are. CSS, JavaScript, red is fonts, purple are images, and the video is down here in green. And so the browser's like, there's a video. Videos are really, really huge. So we're going to download that last so that we don't block the CSS, the JavaScript, the images, the HTML, all that other stuff. But let's talk about the video user experience and how we put video on a web page. So we're going to start off with just the video tag. The video tag has been around since 2008. It's part of HTML5. You just take the video tag, you can insert a source, you point it to where your MP4 or your video file is. This won't work. You can add the attribute autoplay, and the autoplay attribute is Boolean. So if it's there, that means autoplay. If it's not there, that means don't autoplay. This won't work on mobile. It will work sometimes on the desktop, but it's really, really hard to test. And the problem is what most browsers do is they have their own logic as to when autoplay will work. So you oftentimes need to interact with the page. Or if you've interacted with the page in the past. So it has this like heuristic that you've been to this page before and you've interacted. So then we're going to autoplay all the videos on this page. When you're testing, that's really, really hard to figure out, because you're loading that same web page over and over and over again. And is always going to autoplay for you, but you don't know if that's actually going to be the case for your customers because it may just be their first time to the page. Incognito mode or a fresh browser, an anonymous user in your Chrome or whatever is a good way to test this. If you add the muted tag, now muted, of course, means that the video will have no sound, but this works on mobile. And so Chrome, Firefox, Safari have all set it up so that if you have autoplay and muted set on the video will play on mobile. Of course, there'll be no sound. This is, of course, so that you don't have to deal with, so that your users don't have to deal with blasting, the bus or the public space they're in with the video that they're watching. It also means that when you're in a meeting and you're not really paying attention, you don't get busted because this loud video starts playing, right? You scroll past something on Twitter and it starts blasting music. We don't want that to happen because then people know you're not paying attention in the meeting. For all of you who aren't paying attention, I'm joking. You can also add controls. So if you don't have the controls attribute, you won't have the play, pause, and the bar at the bottom. If you want the play, pause, and the bar at the bottom, you have to add the controls attribute. You can set a width. You can set a height, right? This is sort of, standard, kind of like what you do with an image. Most people just set the width because you don't want to screw up the aspect ratio of the video. So if you set the width, the height is automatically defined for you. If the video isn't auto playing, what the browser will do is it'll pick the first frame of the video and use it as a poster. If you don't want to do that, you can set your own poster. And so you can have your own image there. Maybe it's, you've seen this on like YouTube, right? Where they pick a specific frame that they want to show for the poster, and you can do that as well. You can add a loop parameter. So of course the loop parameter says when you get to the end of the video, start over at the beginning again. This makes your video look like an animated GIF. And this is actually a huge thing to do because GIF files, the GIF was designed in 1987 or 1989. There's two specs for it. And, compression wasn't really good. And the animated GIF, if you have a 24 frames per second, is literally 24 GIFs every second. They're really, really large. So a video has better compression. So if you have a video and you use autoplay muted loop, it looks like a GIF. No one knows the difference. If you actually ever look at the source code for like Giphy.com, or if you look at Slack and Facebook, everyone that uses GIFs and they call them, hey, you're inserting a GIF, you're actually inserting a looping video just because the file is so much smaller. Another thing you can set inside the HTML5 video tag is the preload attribute. And this tells the browser like how much do you think the person's actually, your viewers are actually going to watch the video? If you say preload equals none, the browser will be like, I know there's a video here, but I'm not going to download any of it until someone presses play. So that's super efficient from like a load time because you're not going to use any data. It does mean that when they press play, it may take a little bit longer for the video to start up. So in Safari, here's a video where I said preload equals none. 203 bytes for the HTML page, right? Because it was HTML with a video link in it. Preload equals metadata. This is defaults in most browsers. And what this tells the browser is, hey, there's a video, download a little bit of it. So you can know a little bit about the metadata and maybe have like half a second there. So when they press play, you can play that half a second and then start downloading the rest of it. You'll see here in this example, in Safari, we downloaded 600K, right? So the page just got a little bigger just by changing it to metadata. The last option is preload equals auto. And when you do preload equals auto, you're telling the browser like, people are going to watch this video, so just download the whole darn thing, no matter what. And lo and behold, that's what we see. You can see in Safari here, when I use preload equals auto, the entire video is downloaded. The page is now 31 megabytes. So if you think someone's going to watch the video, this is great. But if you think there's only like a 25 or 30% chance, like these are better choices just from a data perspective, especially because you're paying for the bandwidth coming out of your server. Other things you can do is you can use multiple sources. So rather than put the source in the video, the open tag for the video, you can apply different sources. And so this is great because different browsers have different support. Just like with images, there's some that support AVIF or WebP versus JPEG or GIF. You can do the same thing with video. And what the browser will do is it will grab the first video source that it understands. So WebM, VP8, and VP9 are a little bit more modern than H.264 MP4. So the compression's better at the same quality. So browsers that support that WebM will be able to play this version. And if the browser doesn't support it, they can fall back to the MP4. H.264 MP4 has pretty much universal support across all browsers. If you go to Can I Use, it's at like 98.1% right now. But the 1.9% of browsers that don't support MP4 just don't support video at all. So I don't know how you put that. Like, if it supports video, it's going to support the MP4. So like you're missing out on like Opera Mini and some other like browsers like that. Media queries. So in images, there's this idea of progressive images or responsive images where you have a different size image for different size screens, right? And that makes sense, right? You don't want to have a giant 4K image downloaded to somebody's mobile phone because that's just a crazy amount of data. We don't want to do the same thing for movies, but this doesn't exist. You cannot do media queries on videos. It went out of Chrome, I want to say in like Chrome 34. So it's been gone. It was there and then it got pulled out of the spec and it's gone. So the solution for this is streaming video, which we'll get to as we progress through our talk. But I want to talk about some interesting approaches to doing video delivery. And my first example is from a fairly famous gold gilded building in New York City. The former guy, right? We all know who this is. When you load up this page, there's a background video, and you can see that it's showing off all the wonderful things you can buy in this store in this building. So this is the video tag that's inside that web page. And you can see there's a div that's the video container. And then we have a video tag for the desktop video, which loops. And it's Trump Tower, the experience. And then there's a second video tag for mobile video that has the mobile version. Now, the problem with this is what you really want to do is you want to have one video tag and you want to use JavaScript to put in one video or the other video. If you put two video tags there, guess what the browser does? It downloads two videos. So, they're sort of trying to do the right thing, but they couldn't figure out, and they're like, screw it, we'll let the browser figure it out. But what ends up happening is instead of the mobile experience just being a 6 megabyte download, it's a 20 megabyte download where they only experience 6.5 megabytes of the video. So this is the wrong way to do it. Don't do this. Like, if you're going to have two videos, use some JavaScript to insert the one that you want to have downloaded. Downloading two videos for everybody, it's just stupid. Second example. All right. So we've got a video that is looping. It's auto playing. It's muted. It plays in line. Plays in line. You use in. I didn't put that in the video tag. Plays in line is used by iOS. Mobile iOS devices will not play a video unless it's full. Will only play it full screen unless you have the plays in line. And then they have a poster. There's two things going on here. Number one is the video is going to autoplay. It's loop muted autoplay. It's set up that as soon as there's video, the video is going to play. The second thing is, and so why are you downloading a poster? There's no reason for the poster because the video is going to start playing. What ends up happening is you download the poster first and it actually delays the autoplaying of the video and you never actually see it. The second thing is the poster by default is the first frame of the video. So downloading the first frame in the video and then also downloading the first frame as a JPEG is also not required. And then you start looking, and that first frame JPEG that's blocking the video download is 250K. In my test, it took 1.5 seconds. Like that's blocking the video. So if you're going to autoplay it, you probably don't need that first frame. Third example, and this is one that I might actually just do live because it's kind of cool. Come out of that. I'm going to open up a new tab. I'm going to go into DevTools just because that's fun. And then we'll go to climbiowa.com. But before I load it, I'm going to make my screen small. And we're going to look in DevTools, we're going to look for an MP4 file. So if you're on a mobile device, what you see is no video in the background, but you downloaded, if you can see right here, 4.3 megabytes of video. And the reason for that is if I go to a larger screen, we get the video. If we go to a smaller screen, we don't get the video. All right, so what's happening here is, go back to presentation. What's happening here is they're using CSS to hide the video. And so the thing about this is great. It's hiding the video from showing up on the mobile devices, but it's not preventing the video from being downloaded on those mobile devices. So if you're on a mobile device, you're downloading 4 megabytes of video that you'll never see every single time you go. So you're like, where's that climbing gym again? You type it in on your phone, you get the address. You downloaded 4 megabytes of video. You don't need to do that. You should probably, if you're going to remove the video for small screens, you should use JavaScript to remove it. Or you should have no video at all and insert it for larger screens. It makes it weird probably for when people are like sliding the thing back and forth, but like that's Doug giving a conference talk and you as a developer. It's not your typical user. So the takeaway from this third example is display none does not mean download none. You're still downloading the video even if you hide it in your styling. Fourth example, this is a solar website, right? So they would, buy your solar, and the background here, this is a screenshot, so you can't see it. But imagine a drone slowly flying over the solar panel, and you see the light glinting from the sun glinting off the solar panel, right? You can imagine this in your head of what's happening. It's, is a beautiful thing if it worked. On this webpage, it doesn't work. And the reason it doesn't work is is because of the size of the video. And so there's a free tool out there called FFmpeg, which helps you encode and edit and crop and, build your videos. And if you use a tool like Blender, like that's FFmpeg, that's like a GUI on top of FFmpeg. There's a corresponding tool called FFprobe, which tells you what's going on with the video. And I've built an online version, so you can just paste in the URL of your video and learn about the video. So we've got this video of the solar panels, and I wanted to see what's going on with this video. And so the video is 1080p. My wife, I don't know if you can hear the dog in the background. He just gets sad when my wife leaves. He'll be done in a second. And my kids will take care of it. It's a 1080p video. So one thing is like, this video is like not the full screen, but they're still doing like a 1080p video, which is really big, especially on mobile. It's 11 seconds long. That's fine. It's going to play the 11 seconds. It's going to loop, and you're back at the other side of the solar panels, slowly flying over them on your drone. Here's where things get weird. Those are really, really big numbers. And when I see really, really big numbers, I like to add commas. And what we see is this video was encoded at 90 megabytes per second. And the entire size of this video is 120 megabytes. So if you think about that, like, are we actually ever going to see the drone slowly flying across the solar panels? We probably won't, because none of us are going to sit unless we're on a really zoom in connection. Because like, no one's going to wait at the top of the page to see if that's just an image of solar panels or if it's like a cool loop in video. And at 120 megabytes, like that's like 1 megabyte is probably about right for this, right? It's 120 times too big. So, if you're going to put a video online, let's look at the encoding. If someone hands you a video and says, here's a 120 megabyte video, you're like, maybe I should look, maybe I should just Google to see how I can make this video smaller. There are a lot of tools out there that'll help you do that. Last example is, I don't have an example. Oh, I can pull it up. Let's just pull it up. I opened it up earlier today, so it'll be right here. I always like to see if my examples still hold. All of the examples, if you go to the web page, they're still all broken. Not broken, they're just not using best practices. So we see this background of people smoking and like leaning up against the wall, right? They're doing their modeling thing. If you actually watch the MP4, it has audio. And so now we can start talking about like, I'll make this presentation mode again. Like if you have a video that's never gonna play the sound, a background video, a looping GIF, you can actually remove the audio channel from the video and you'll make the video usually like 5% smaller. So think about that. That video, no one's ever going to hear the audio. So why don't you just make a separate version of it, remove the audio channel, and then you're going to use a lot less bandwidth, both from your servers, for your customers. The video is going to load faster. It's just a better experience for everybody. Okay, I have one more example. All right, but that's awesome. This one isn't live anymore. They changed their video. But this is an example of how people make mistakes with the source attributes. And so if we look here, this is a video, you know, it's got its class, it's going to loop. They use JavaScript to autoplay it. So there's not an autoplay here, but as soon as it's loaded, they use JavaScript to autoplay. We have a first source, which is an MP4, and a second source, which is a WebM. Now, the problem with this is, of course, what the browser does is it finds the first source that it knows how to use it, and it's going to use that one. But since 98.1% of browsers know how to deal with an MP4, and the ones that don't do it don't know how to deal with a WebM anyway, if they actually looked at their view rates for the MP4 and the WebM, they'd see 100% of people are watching the MP4 and 0% of people are watching the WebM because of the way they built this. This is systemic. I'm writing a blog post for the State of the Web 2021, and I just did this analysis on all the videos on 7 million web pages, and like almost everyone gets this wrong. So if you're building a web page with video, if you flip these around, you'll be getting it right. The other thing that's really horrible when this website was live is that the MP4 was 73 megabytes and the WebM was 34. WebM is supported in Firefox and all Chromium browsers. It's not in Safari. Like that's the switch, right? But if you imagine, I think that's like 60, 70% of browsers. Imagine if you could use half the data for all of those. You know, that would be a huge, you know, it would load a lot faster. It'd be a better experience for all the people in the Chromium browsers. Of course, they could have made this MP4 a lot smaller. That's a whole other story. The other thing about this story is that they're hosting their videos at AWS. And so if it's 9 cents a gigabyte for data transfer, and you're serving 73 megabytes every single time somebody loads the web page, your hosting costs are going up really, really high. Like S3 is great, but the egress, you know, you're going to pay for that every single time a video is downloaded. So summary on all my examples of what not to do: use JavaScript to serve the correct video, you know, the Trump Tower, right? Only serve one video. Put them in the right order if you have multiple videos using the source tag. If you're going to autoplay the video, you don't need the poster image. You don't want to use display none. Resize your videos so you're not killing people's data plan. If it's silent, you can remove the audio and then order the formats correctly. Like with those things, you can use the video tag and you'll be super successful. Like it's gonna be such a better experience for your users. So I'm going to switch gears just a little bit here, and this is more into like the compression idea of using videos. So like here I've got this 1080p video. This is actually from my alma mater in Ohio. It's 5 megabits per second. And if I'm on a fast Wi-Fi, you know, if it's over 5 megabits per second, like it's going to fit through the tube and it's going to show up on my phone just fine. When I was writing this talk, I was actually preparing to give this talk in Germany, and the Wi-Fi sucked. Like, I don't know, like they put me in like the corner room, that as far from the router as they possibly could. Like, it was awful. I tethered my phone because in Europe that's cheap, whereas in America they don't make that cheap for you. And the problem there is, of course, as you try to fit 5 megabytes down a 3 megabyte pipe, it doesn't fit and you get a spinner. And so we don't want spinners, because when video has a spinner, like, that's bad, right? Spinners are bad. When people can't watch the video, they're going to abandon the video. They may abandon your site. So we always want to make sure that the video is going to play. So how do we size the video for your end users? The first thing we can do is we can resize the video, right? If I'm serving a video that's 1900 pixels wide and my phone in portrait mode is only 1080 pixels wide, we can resize it. We don't have the media queries, so you can create multiple sizes and then use JavaScript to insert them. So you could create a 1080p, a 720p, a 480p, and then use JavaScript. Say, what's the size of the screen? Oh, okay. Insert that video. And that sort of gives you the idea of a responsive video delivery. What that doesn't fix is if the network goes to heck. What if you resized it here and what if you resized it here and your network wasn't good enough to show even the 720p video? It's sort of weird. Like, when I think of web development, we all kind of measure things in width, but video is always measured in height. So 720p is the height of the video. So the answer to that is video streaming. And so we're going to talk about video on demand streaming. So video on demand is like, any video, like YouTube, Netflix, Hulu, Disney Plus, all of those things. We're watching video on demand. It's streaming video but you can play it on demand. It's not live. There's two different types. There's HTTP live streaming, or HLS. This was invented by Apple and is the predominant mode today. And then we've got DASH, dynamic adaptive streaming over HTTP. Now, HLS, it says live streaming. It doesn't have to be live. So that's sort of like one of those things where they put a word in there and it doesn't really help, because it can be a recorded video and still be on HLS. Dash is actually the industry standard, but because Apple, everyone's using HLS still today. There's a little Dash usage out there, but most everyone is still using HLS. I'm going to talk about HLS just because it's for predominant form today. So what happens is you've got a video, and what video streaming does is it breaks your video into segments or chunks. I kind of use those two words interchangeably. In HLS, you'll see a .ts file. In Dash, you'll see .m4s, right? Those are just the names of the segments that is broken up. They're usually 2, 4, 8, you can cut them up any size you want. Seconds long, sorry. There's a text file, it's called a manifest file, that describes the segments. And so it looks something like this. It'll say like, well, here's the first segment, here's the byte range, and here's the file. Second segment is 3 seconds. Here's the byte range, there's the file. The next one is 6 seconds. Here's the byte range, here's the file. And so the video player is like, I need the next 3 seconds. And so it downloads these byte range, and then it downloads like that byte range, right? So the manifest is sort of like, all right, you need more video, here's where you can find it. And then the player makes the request and downloads those segments. You can see the target duration is 10 seconds. This is just like the header. And then here are the different byte ranges. Where streaming gets really interesting is you can create multiple streams. And so you can create a 360p, a 720p, a 1080p, a 4K if you wanted to, an 8K if you are really ambitious, but like, how many people really have an 8K TV that are going to be watching it? It's just going to be a mess of data on your server. 4K is probably good enough. So now you have different manifest files, one for each size. And that's great because each one of these because they're different sizes, you know, the size of the video makes a difference into how big the video is and the bit rate of the video. So, you know, 1080p might be 4 megabits per second, 720p might be 2.5 megabits per second. Now we can also adjust the playback based on the network speed. So what if you had a big screen, but you were on a really, really poor connection? We can still serve you the 360p. It may not look great, but it's going to play. You're not going to get the spinner. If all of a sudden, you know, the cloud's clear, your cell coverage gets better, we can jump you up to the 720p or the 1080p. To decide which one of these to describe these different streams, we have a parent manifest. And that parent manifest looks something like this. And so basically you have a line that describes each one of the streams, right? When I look at these, I tend to look at it this way, right? So here is the bandwidth of the different streams. So if the player knows the speed of the network, it can pick the biggest one. It also knows the codecs that are available. Oh, I'm on a browser that doesn't support this codec. I can do something else. In general, streaming is all H.264 MP4 because like 98.1%, right? And then we've got resolutions. And so now the player can use the bandwidth and the resolution to find the exact right, you know, not too hot, not too cold, just right, you know, the Goldilocks approach. We'll find the right video that will play based on your network speed and the size of your screen. And what's great about that is now it's responsive, it's excuse me, it's network aware, it's adaptable, it can change midstream. Remember, each one of these segments is 3 to 5 seconds long. So if all of a sudden, you know, you're watching a video and then all your kids upstairs on all of their machines start watching videos and your bandwidth goes down, your player may adjust to take care of, to make sure that it still plays. The quality may go down. Or conversely, all your kids are up, you know, taking school classes on Zoom. They get off their Zoom call, your video quality gets better because you have more bandwidth. So it's completely network aware and adaptable. You get faster video startup, and this is sort of a trick. And the way that trick works is you can start up the video at 360p. It may not look great, but those segments are really, really small. So the video starts up really, really quickly. And then it can quickly jump up to the 1080p video. And you may notice this, like if you're watching a Netflix, the first couple seconds, it's usually a black screen anyway. The quality may not be ideal. And that's because it can get that video starting super fast and then jump to the higher quality before anything shows up on the screen. All right, let's just jump to here. All right, so that's why I think video streaming is sort of the future for longer videos. If you have a shorter video, like under a minute, the video tag is great. But once you get started to over a minute, it's really helpful to have a responsive, network aware and adaptable video setup so that it works for all of your users, no matter where they are in the world and how it works. This is my shameless plug slide. I work for api.video, where we do this. You upload your video, we will create the HLS stream for you, and we'll give you a URL that you embed on your web page with analytics. And so if you're interested, check it out. No pressure, but if you're interested, it can help you along the path. And we have lots of tutorials about all this. And if you reach out in the chat there, like, you might be talking to me. So with that, thank you so much. It looks like I stopped a couple minutes early, so we can have some room for questions and discussion if we'd like to do that.
Awesome. Thank you so much, Doug. It was really a lot to learn from you. And I'm so excited actually to say that this speaker came through the Google development groups, and Doug has the GDE, Google Developer Expert title. Would you like to say a few words about this GDE thing?
Sure.
Just before you do, Doug, I just want to say, if you do have a question, please put it in the chat.
Yes, please.
Yeah. All right. So GDE, Google Developer Experts. Basically, the way I look at it, and it's a way for it's a completely volunteer thing. Like, I don't work for Google. but it's basically a recognition from Google that if you're a GDE, you've got some experience in your GDE field. There's like 12 different categories of GDE. I'm a GDE for the web, but they have GDEs for cloud and for maps and for Android. They have a bunch of different categories, and it's basically shows it's a recognition that you've been serving the community with what you've learned. So you're not only an expert, but you also work really hard to share that with the community. And so the way I look at it, it's sort of recognition that from Google that, hey, this person knows what they're talking about and is also an educator to share about that. And so what's great about that is it also makes, for if you're an organizer like Ulia, it makes it very easy to find people who, Google says, hey, this guy or gal kind of knows what they're talking about. Or sort of a badge that when somebody comes up to you and says, hey, I'd like to talk about this, and I'm a GDE, it's sort of like that stamp that Google says that, hey, this person kind of knows what they're talking about.
I also appreciate the fact of connection they are making, because we discovered Doug, and I think he is awesome. And this topic is very timely, specifically in this time, right? We're all in. Content is the king, but now video is the king. We're all in video. And yesterday we had a very interesting discussion about digital divide and came to conclusion that the internet will be always hungry for more capacity because more video is coming.
It's sort of like when you're in a city and they want to add another lane to the highway, right? As soon as that other lane is added, the traffic still sucks, right? It's going to be the same on the internet. As we add more and more speed, we're going to clog it up with whatever it is. And I really do think that we're on video has been big on the internet for a long time, but it's always been consumed, right? We watch a lot of video because download speeds are fast, but now we've got 5G, which is really, really, really fast upload. Now anyone can be a creator from anywhere in the world, and you can upload your videos really, really fast. So it's no longer like it's going to be still a consume model, but they're going to be so much more to consume from so many different places because anyone can upload a video.
So true. Do we have questions from the audience? John, can you read it out loud?
Yeah, sorry, I had to find my mute. So Taryn is asking, what technical implementations are suggested for live stream of hologram videos in 4K?
I'm not sure exactly what a hologram video is. I'll be honest with you. So if you want to type something in there, that'd be awesome. I think one thing is when you're streaming in 4K is be aware that not everyone's going to be watching in 4K, right? So much video is consumed on mobile devices, and when we stream 4K, we're talking 16 megabytes a second, and just not everybody's at that speed yet. So a lot of people are going to be on smaller speed than 4K, and honestly, my mobile phone can't even use that many pixels, right? It's going to want the 1080p because my phone isn't a 4K screen, even if I was at full size. So streaming is the way to go for that because you get that responsive delivery, especially if you're going live. Well, if you're going live, you're streaming anyway, but you get that responsiveness to it. So that's really important. Hologram videos, I'll wait till there's something more about that one because I guess we're looking at stuff in 3D.
Arun, if you're here, you can unmute yourself and ask.
Oh, okay. So you're filming on a green screen and then you're making it, okay. Okay, so you're sort of like right here, I'm not actually outside with water behind me. right? Zoom is doing this for me, right? Zoom is figuring out, you know, I just don't want you to see all the crap that's right behind me. And so I added this, the green screen. So yeah, there we go, right? We can, but generally you're going to do that on before you start streaming, right? So if you think about what Zoom is doing this background on my computer. And if you have a, my kids actually have my old MacBook, which is a 2011 MacBook Pro, and Zoom won't do the background on that computer because it doesn't have enough horsepower to do the background video, especially not a background video. That's all done on your end. That's like pre-processing before you stream it. So tools like OBS can do that for you. So if you're using OBS, you can actually add things in front and you can overlay different camera angles. I've also built some demos. If you want to do it in the browser, you can do that as well. If you want to try that out, I've got a demo at record a video. I'll just type that in the chat, record.a.video. And what that does is it shares your screen and it shares your camera and then it overlays them. So my background is my laptop screen, and then I'm in the corner. I don't do any green screen stuff on that. I just put a box with me and all the crap that's behind me in the little box. But you could do that with the green screen. Tools like FFmpeg can do that. I think OBS can also do the green screen. I just haven't played with it. If I go like this, you can see like Zoom kind of forgets. Oh yeah, see, there's my son's coat, right? You can start to see like as I move around what's behind me. So I sort of think like anything you put onto the video is pre-processing before you send it out. And your computer, that you have, assuming it isn't like a 2011 MacBook Pro, like the one I gave my kids, you can do most of that. I've got a 2020 MacBook, and OBS is sort of like it turns on your fan even if you have it running. It's just like OBS just turns on your fan because it's getting ready to do whatever you want to do. So it does take some processing power to do all of those things, but it can do that just right on your computer. For record a video, the way I do that is I take video inputs in, draw them to a canvas, and then stream the canvas out. So you can do that with just with HTML5 and JavaScript and the web media APIs. Unfortunately, they don't work that great on Safari. I'm still trying to make it work, but there's just some of those APIs are still considered experimental. I know WebKit or Safari 15 is coming out really, really soon, or just did. I've got to go look. I just haven't had time to do it yet.
Thank you. Nice tips, actually. Thank you very much. Do we have any more questions from the audience right now? Or shall we switch to a few networking things?
I think we're good to move on.
Thank you,
Awesome.
Doug.
Thank you so much for having me.
Yeah, thanks, Doug. It was a great talk. Really interesting. Thanks so much.
Awesome.